Direct and indirect slash inverse proportion. This is a super important video, guys, because these kinds of questions appear in pretty much every single past paper. These are more like level 7, level 8 questions, but in my opinion, they are the easier level 7 and level 8 questions because there's pretty much one single framework. Once you've got the framework down, you can pretty much apply to every single one of these questions and it's going to be easy marks, okay? So I highly encourage you to get this topic down because it's going to score you a lot of points, okay? So let's get into the definition of direct proportion. Okay, the first thing we're going to discuss is the word proportion. Proportion is a way of describing a relationship between two variables. If I said x is proportional to y, that means there is a relationship between x and y. And if the relationship is direct, that means as one variable rises, the other also rises. Or on the flip side, as one variable falls, the other also falls, okay? So we can illustrate this on a diagram. Let's say our two variables are x and y, and they're directly proportional. That means as x rises, y will also rise. So as x rises, y will also rise. And as x falls, y will also fall. So as x falls, y will also fall. So a directly proportional relationship always looks like this in terms of a graph, okay? Let me give you an example of two variables which are directly proportional to each other. How about this? Time spent studying and grades. There is usually a directly proportional relationship to time spent studying as grades. The more time you spent studying, the higher your grades will probably be, okay? And also on the flip side, the less time you spent studying, the lower your grades will probably be, okay? So hint, hint, guys, study. So we can always graph this. Well, our x-axis is what we can control. We can control our time spent studying, and we're measuring our grades. So the more time spent studying, the higher your grades will probably be. Hence, this is called directly proportional, okay? So let's get into some questions about direct proportion, all right? And let's learn this framework. Okay, question 1. A is directly proportional to B. When A is 12, B is 3. Find a formula for A in terms of B. Let's just do part A first. Find a formula for A in terms of B. Okay, let's break this down. A is directly proportional to B. Well, what did we learn earlier? If they're directly proportional, as A rises, B also rises. If you want, you can draw a graph. A and B. It'll look like this. As A rises, B rises. And what do we know? When A is 12, B is 3. If we want, we can graph this too. If A is 12, let's just say 12 is here, B is 3. Oh, that was not. If A is 12, B is 3. Find a formula for A in terms of B. Okay, so the first question, find a formula for A in terms of B. This question can look like this, or this question can look like this. Write A in terms of B, okay? The first question, part A, is always worth 3 marks, okay? Because there's a 3-step framework. And once you get this framework down, it's going to make B and C super easy, and it's just really easy marks. Step 1, guys, we have to make a proportion statement, okay? How do we do this? We just look at the first line only for the proportion statement. A is directly proportional to B. We have to turn this into mathematical notation, all right? So how do we do it? Well, we start with this. A, we'll skip the word directly. A is proportional to B. In order to turn the word proportional into mathematical notation, we do a little fish sign like this. So A is proportional to B, okay? Now, if it's a directly proportional relationship, we have to introduce something called a constant, okay? A constant, we call it, I'll call it constant because it's usually called a K, is the rate of change, all right? Okay? Now, if A is directly proportional to B, there will be a constant and it'll be multiplied to B, all right? When we do indirect proportion, it'll be slightly different. Whenever things are directly proportional, it'll be the constant times the variable, okay? So for example, if C is directly proportional to D, if we were to write a proportion statement, it would be C is proportional to D, and since it's directly, it'll be K times D, okay? So whenever things are directly proportional, it'll be the constant times the variable, K times B or K times D, all right? And that right there is 1 mark, guys. Proportion statement, 1 mark. Step 2. We have to plug in the values and solve K. We know when A is 12, B equals 3. So all we're going to do is we're going to replace A with 12 because we know A is 12. We're going to turn the statement into an equation, so we need an equal sign. So 12 is equal to K times B. B is 3. All right, so we made an equation. Let's solve for K. So K times 3 is 12. This one's pretty obvious. K must be 4. 4 times 3 is 12, so K is 4. And that's the 2nd mark, guys. We found K. Step 3 is the equation. What we're going to do is we're going to just go back to part 1, and we're pretty much going to rewrite it in terms of an equation. So we're going to write A. Since it's an equation, we're going to replace the fish sign with equals. We know K is 4 from here, and times B. And that's the final answer for part A. That's it. You write your proportion statement, you plug in the values and solve for K, and you write your equation. Find a formula for A in terms of B. Well, here's our formula. Here's a formula for A in terms of B. Or here, write A in terms of B. So that's our answer to part A, okay? It's a 3-step process. Now let's do question B, okay? That's a terrible color. Find the value of A when B is 5. All we're going to do here, guys, is use our equation we found from part A. So A equals 4 times B. And what do we know? Find the value of A when B is 5. So what we're going to do is we're going to replace B with 5. And we're going to find A. So A is equal to 4 times 5. So A must be 20. Cool. We found the value of A. A is 20. And then for C, find the value of B when A is 36. So we're going to go get our equation again. So A equals 4 times B. This time we want to find B when A is 36. So we'll replace A with 36. So 36 is equal to 4 times B. So 4 times something is 36. If you want to be technical, you can do 36 divided by 4. But I just know 4 times 9 is 36. So B must be 9. And that is your answer, guys. So basically, the main marks are made in the first question, finding the formula part, okay? So to do that, you use this 3-step process. And once you do part A and find the equation, question B and C are super easy. All you're going to do is just substitute some values in and find A and find B. It's going to get a little bit harder soon in the next sections, as you'll see. All right, guys, let's get a little bit more tricky. Here we go. H varies directly to the cube of C. When H equals 40, C is 2. Express H in terms of C. So now it's very much the same question, but the vocabulary is a little bit different. H varies directly to the cube of C. Varies just means there's a proportional relationship, okay? So varies means that are proportional to each other. Proportional to each other. So H varies directly to the cube of C. When H is 40, C is 2. Express H in terms of C. Express H in terms of C just means write an equation for H, okay? So straight away, guys, I noticed that this topic is definitely a proportional relationship problem. Hence, we should just use our 3-step framework. That's what goes on in my mind when I see these questions. As soon as I see the idea of varies directly or is directly proportional, I just think straight to my 3-step framework, okay? Right an equation for h. So step 1, we're going to do our proportion statement. So h is proportional directly to the cube of c. So h is proportional to not just c, but the cube of c. And it varies directly, so it's going to be k times c squared. So that's step 1. Okay, let me bring that h closer. H is proportional to the cube of c directly, so it's k times c cubed. Step 2, plug in the numbers. When h is 40, c is 2, so h is 40. We'll turn this into an equation, so equals k times c is 2, so 2 cubed. I'm going to solve for k. 40 equals k times 2 cubed is 8. All right, so something times 8 is 40. We can do 40 divided by 8, or just think about it. 5 times 8 is 40, so k is 5. And then step 3, we're going to write our equation based on the first step. So h, it's an equation, so it has to be an equal sign. We know k is 5 times c cubed. And that's our answer for part 1. So we just use our 3-step framework again. H equals 5 times c cubed. Find the value of h when c is 5. So I'm going to use my formula that I found. H equals 5 times c cubed. Find the value of h when c is 5. So I'm going to replace c with 5. So h equals 5 times c is 5, 5 cubed. H equals, well, I can just put this into my calculator. 5 times 5 cubed is 625, I'm pretty sure. 625, and that's our answer. So like I said, guys, 3 steps. 3 marks for the first question, always. Next question, find the value of c when h is 5,000. Okay, let's go back to our equation. H equals 5 times c cubed. Find the value of c when h is 5,000. So now we know h is 5,000, so 5,000 equals 5 times c cubed. All right, a little bit harder, this equation. Well, I don't know. There's a few ways we can do it. Let me show you all the ways. Well, the way I do it was as I think 5 times something is 5,000. Well, c cubed must be 1,000 because 5 times 1,000 is 5,000. So c cubed is 1,000. To get rid of the cube, we can cube root 1,000. So c is equal to the opposite of cubing is cube rooting. The cube root of 1,000. So just putting that in your calculator, it'd be 10. Another way is you can solve it like this. 5,000 equals 5 times c cubed. C is being cubed, then times by 5. Since the goal is to get c by itself, we're just going to work backwards. So c is being cubed and then timesing by 5. So we're going to work backwards, so we're going to get rid of 5 first. If it's times by 5, we're going to divide both sides by 5. 5,000 divided by 5 is 1,000 equals c cubed, because those cancel out. And now to get rid of the cubed, we cube root both sides. So cube root 1,000 will give us c, and that's going to be 10. That's another way of doing it. And that's it, guys. Final question, probably a little bit tougher. A is directly proportional to the cube root of b. B is increased by 60%. Work out the percentage increase in A. All right. Well, I see a statement about our proportions. So let's make up a proportional statement about this sentence for 1 easy mark. So even if we don't do anything else, as long as we get a statement out, we're going to get 1 mark. So A is proportional to the cube root of b, and it's directly proportional. So it's k times the cube root of b. And that's 1 mark right there. B is increased by 60%. Work out the percentage increase in A. Oh, damn. So in the last few questions, we were given two values for h for the 2 variables, all right? H is 40, C is 2. In the question before that, it was when A is 12, B equals 3. In this question here, we're not given two values for the variables. All they said is b is increased by 60%. So what we can do, guys, is one way is we can make up our own variables. Let's say, I don't know, a is 2 and b is, I don't know, 100. And let's plug a and b into this statement and find k, like in our usual step 2. So a is 2, so 2 is equal to k times the cube root of b is 100. Well, we shouldn't use 100 because it's impossible to, it's going to be give us a really ugly number when we try and cube root 100. Let's change b to a cubed number. So what's a cubed number? Let's do 27, because 3 times 3 times 3 is 27. So 27 can be cube rooted. So we'll say b is 27. So whenever you're not actually given any values for a and b, just make them up. When a is 2, b is 27. Like that. And it might give you a fresher idea how to do the problem. So that's so let's find k. So 2 is equal to k times the cube root of 27 is, you can use your calculator, is 3. So k times 3 is 2 if you're stuck. K is being multiplied by 3. If we want to find k, we got to divide by 3 to both sides. So it's going to be 2/3 is equal to times 3 and divide by 3, cancel out, is k. So k is 2/3. So our equation will be a is equal to k times, k is 2/3 times the cube root of b cubed. And that's an equation we've just made up, okay? Now, we said a is 2 and b is 27. And now what's happened is b has been increased by 60%. So let's increase b by 60%, okay? Plus 60%. Remember how we do this, guys? We've used a multiplier to increase 27 by 60%. We're going to do 27. 27 is our original amount, hence it's 100%. We're adding 60%, so we're doing 160%. Turn that into a decimal by dividing it by 100. I'll write it down. It's 160%. We'll divide that by 100 to give us to 1.6. So we're going to do 27 times 1.6, which is 43.2. So our new b value is 43.2, equals the second b value. And now let's try and find the new a value by using our equation. So a is equal to, our k is 2/3 times the cube root, and our b value now, after it's being increased by 60%, is 43.2. So a is equal to 2/3 times the cube root of 43.2. You can just use your calculator. 43.2 power of cube rooted, that is about 3.51. So a is equal to 2/3 times 3.51, which is 2.34. And that's our value for a. New value for a. Now we have to find the percentage increase in a. So a was originally 2, and now it's 2.34. Do you guys remember the percentage increase formula? Super important. Percentage increase is the formula for a percentage increase or percentage decrease or percentage change is the change over the original value times 100. Well, the change from 2 to 2.34, we can just subtract them. So the change is basically the new value minus the old value divided by the original value, which is 2, times 100 equals 2.34 minus 2 is 0.34 over 2 times 100, which is equal to, let's just do it all in one go, divide by 2 times 100 is 17%. And that is our answer, guys. If b is increased by 60%, a is increased by 17%. So in this question here, we weren't actually given the phrase when a is 2, b is 27. We just made it up, okay? So I got my proportionality statement from the first sentence. I plugged in 227, found my equation. All right. Then B was increased by 60%. So I increased my B value by 60% by timesing it by 1.6. So our new B value is 43.2. So I use my equation again, replace B with 43.2. A was 2.34. Then I use my percentage change formula to find the percentage change, which was 17%. And in the next chapter, we're going to be doing inverse proportion. That was it for direct proportion. Here are 4 questions you're welcome to try about direct proportion. Probably do it best in this order. So first question here, second question, third question, and you can leave this for the last question, all right? I've given you a hint on the last question, okay? Thanks so much, and next we'll get into inverse/indirect proportion. Gang, the next kind of proportion you have to know about is called inverse proportion. Inverse can also be called indirect, all right? And inverse proportion is pretty much the exact opposite of direct proportion. If direct proportion states that as one variable rises, the other also rises, inverse proportion states that as one variable rises, the other falls, and vice versa. As one variable falls, the other rises, okay? So if we were to put this in a graph, let's say we have 2 variables, x and y. As x rises, y falls. As x falls, y rises. The graph for inverse proportion would look like this. As x is getting larger, y is falling like this. And this is a graph for inverse proportion, okay? Let's think of some examples of inverse proportion, where one thing rises, the other falls. How about this? Time spent in the gym. As you spend more time in the gym, your body fat percentage will probably go down. And the less time in the gym, less time you spend exercising, your body fat percentage will probably go up. All right, so we put this in a table, in a graph. Time in gym, your body fat percentage. As you spend more time in the gym, your body fat will eventually drop, all right? So that's what inverse proportion is. As one rises, the other falls, all right? And we'll do some questions, okay? And you'll see how similar inverse proportion questions are to direct proportion questions. Guys, let's hop onto some questions here. The time taken, t seconds, that it takes a water heater to boil water is inversely proportional to the power p watts of the water heater. When P equals 2000 watts, T equals 252 seconds. Find the time it takes to boil water when P equals 800 watts. So let's just digest this really slowly. And let's see what we have to do. The time taken to boil water is inversely proportional to the power. So let's underline some keywords. So the time taken, which is t seconds, is inversely proportional to the power, which is P, of the water heater. What that means, guys, is that as T rises, the relationship between T and P is inversely proportional. So as T rises, P will drop, okay? So step 1, let's just write our statement out. Now, whenever we do inverse proportion, our K value, our constant, is going to be placed somewhere else. So let's get started. So T is proportional to P. Now, whenever we do inverse proportion, our constant is going to go above P, all right? So T is proportional to K divided by P, all right? That's our step 1. Let's write our statement out. When P is 2000 watts, T is 252 seconds. Find the time it takes to boil water when P is 500 watts. So in order to find out the time taken when power is 800 watts, we have to find our formula, and we can do it based on the information that we have so far. So step 2, let's go ahead and find K by plugging in our values. So when P is 2000, T is 252. So T is 252. we can replace the proportion sign with equals k over p. P is 2,000. Now we have to solve for k. Well, k is being divided by 2,000, so to get rid of that divide by 2,000, we can multiply both sides by 2,000 times 2,000. So what's that going to be? One sec, sorry. $504,000 is equal to, well, divide and times cancel out, is equal to k. All right. So our formula, so we're still just using our three-step framework from the last question. Statement, find k, and formula is t, instead of the proportion sign, it has to be equals to. Our k value is 504,000 over k. All right, and that's how you get the first couple marks, just giving the formula. And now we can use our formula to find the time taken when p is 800. So we'll use our formula, t equals 504,000 over, over p. What am I doing? Over p. We know we're trying to find the time, so we're trying to find t, when the power is 8,000, so 800. So we'll replace p with 800. So t is equal to 504,000 over 800. So 504,000 over 800. 630. So it'll take 630 seconds. So do you see, guys, how this question was super similar to the direct proportion problems? It was just the only difference is that the constant is on top of p, not being multiplied by p. So same thing, statement, find k, use your formula. Here they didn't specifically ask for the formula, but you should always know that you should always do the formula anyways. Once you get your formula, you can plug 800 into our formula, into p, and then you can find t. Let's move on to some harder problems. Question, the force F newtons exerted by a magnet on a metal object is inversely proportional to the square of the distance d centimeters. When d is 2 centimeters, F is 50 newtons. Express F in terms of d. So express F in terms of d, that means we've defined our formula for F, okay? So we'll just go back to our three-step framework. Step 1 is our statement. The force, F, exerted by a magnet on a metal object is inversely proportional. So proportional inversely to the square of the distance. So d squared, the square of the distance. Step 2, we're going to find k. So when d is 2, F is 50. So we'll replace F with 50. We'll replace the fixture with equals. K over distance is 2 and d squared, so 2 squared. So let's simplify that. So 50 is equal to k over 2 squared is 4. To find k is being divided by 4, so we'll times both sides by 4. 50 times 4 is 200 equals, that cancels out, k. So our formula is F is equals to, our k value is 200 over d squared. And that is our answer for part 1. Okay, that's our formula, which we'll be using for the next few questions, I believe. Find the force when the distance between the magnet and the object is 10 centimeters. So I'll get my formula. And we have to find the force when the distance is 10. So I'll replace d with 10. F is equal to 200 over 10 d squared. So that's F is equal to 200 over 10 squared is 100. And 200 divided by 100 is 2. And that's your answer for the second question. Find the distance between the magnet and the metal object when the force is 8N. So now we're trying to find the distance when the force is 8. So I'll replace F with 8 is equal to 200 over d squared. All right. To solve this, I guess there's a few ways of solving this. One thing I like to do when I'm kind of stuck in a problem like this is I like to do something called the easy example method. Okay. All this means is 200 divided by d squared is 8. So it's basically a division problem. What I do is I think of a really easy division problem myself. Like 5 is equal to 10 divided by 2. Do you see how this looks very much like this? In this case, in our question, we're trying to find d squared. Hence, we're trying to find 2. In order to find 2, we have to do 10 divided by 5. Therefore, to find d squared, we have to do 200 divided by 8. We're just following the same process as we are doing to solve this problem, and we're just copying it to this problem. 2 is 10 divided by 5, so d squared is 200 divided by 8. So 200 divided by 8 is 125. No, sorry, 25. So 200 divided by 8 is 25, so that's going to be equal to d squared. So something squared is 25, pretty obvious, d is 5. Another way, opposite of square is square root, so you just have to square root 25 and you'll get 5. Last question, explain what happens to f when d is halved. Okay, one way we could do this, guys, is just make up your own example. So kind of like the easy example method. What happens to f when d is halved? I'll just choose two values for d. D can be 8, and then I have to half it. D is halved, so d can be 4. So I'll put d into 8 as 8 into my formula, and I'll put d as 4 into my formula and see the difference. So let's use our formula and solve when d is 8. So f equals 200 over 8 squared. So f is equal to 200 over 64. 200 over 64 is 3.125. So when d is 8, f is 3.125. And now I'm going to half d, so d is 4. So I'll use the same formula. F is equal to 200 over d squared, so 4 squared, which is going to be 200 over 16. 200 over 16 is 12.5. All right. And what you can notice, guys, is that this value of f is 4 times bigger than our first value of f. So d, what happens to f when d is half? F is quadrupled. It was at 3.125, and now it's at 12.5. It was multiplied by 4. It was quadrupled. And you can choose another easy example to double check, all right? Final question, guys. A is directly proportional to the square root of c. W is inversely proportional to a cubed. When c is 49, a is 35. When a is 2, w is 16. Find a value of w when c is 4. Oh my, I see 2 proportional statements, okay? So what we can do, guys, is we can find a formula for each statement. So let's start with the first statement. A is directly proportional to the square root of c. So step 1, statement. A is proportional to the square root of c directly, so k times c. We know when c is 49, a is 35. So a is 35, so 35 is equal to k times the square root of c is 49. 35 is equal to k times the square root of 49 is 7. So something times 7 is 35. Well, k must be 5. 5 times 7 is 35. That's step 2 done. And step 3 is going to be a is equal to k is 5, k times the square root of c. So we've found a formula linking a to c. Now let's find a formula linking w to a cubed. So we know w is inversely proportional to a cubed. So w is proportional to a cubed, and it's inversely, so the constant's going to go on top, like this. So that's our step 1. Step 2, let's find k. So when a is 2, w is 16, so w is 16 is equal to k over a is 2, so 2 cubed. 16 equals k over 2 cubed is 8. To find k, it's being divided by 8, so let's times both sides by 8. that's going to be 128. And divide 8 times 8 cancels out, so just k. So our answer is going to be W is equal to k, k is 128 over a cubed. All right? So now we have two formulas. And the question is asking us, find the value of W when C is 4. Well, out of these two formulas, C is here. So let's just plug C into 4 here. So A is equal to 5 times the square root of C is 4. So A is equal to 5 times square root of 4 is 2. A equals 10. Find the value of W when C is 4. Well, now I can find W because I know my A value is 10. So W is equal to 128 and A is 10. So 10 cubed. W is equal to 128. 10 cubed is 1,000. And that's 128 divided by 1,000 is 0.128. And that is your answer, okay? We'll do one more question and I'll give you some problems to do, okay? And last question. Also similar to the last question, where there's like a mix between direct and inverse proportion. Let's have a look. X is directly proportional to W squared. When W is 4, X is 48. Y is inversely proportional to X cubed. When X is 2, Y is 14. Find the formula for Y in terms of W. So I got to link Y and W. First things first, I notice a relationship between X and W squared. So let's just find our formula between X and W squared. So X is proportional to W squared. And since it's direct, it's going to be K times W squared. Step 1. Step 2, let's plug in our values for W and X. So X is 48. Fish sign, I'll replace it with equals. I'll make it a formula. K times W squared. So W is 4 squared. So 48 is equal to K times 16. Something times 16 is 48. K is 3. You can just do 48 divided by 16. So our formula is going to be X is equal to K is 3 times W squared. Cool. Let's make a formula for these two terms. So Y is proportional to X cubed, and it's inversely proportional, okay, to X cubed. So let's find our K value. So Y is 14, so 14 is equal to K over X cubed. Well, X is 2, so 2 cubed. So 14 equals 4 over 8. We'll multiply both sides by 8 to get rid of the divide by 8. 112 equals K. So our formula is Y is equal to K is 112 over X cubed. So these are our two formulas. Now, we have to find a formula for Y in terms of W. So this part's a bit tricky. So we have two formulas. The trick here, guys, is to look at both formulas and see what variable is in common. Well, this formula has X and W. This has X and Y. So both formulas have an X in common. So let's make X the subject of both equations, because that's what's in common. So X is in common of both formulas. Therefore, make X the subject. When I say make X a subject, that means get X by itself, or isolate X. So the first one's already done for us. X is by itself. X is equal to 3 times W squared, basically 3 times 3W squared. But this equation here, X is not by itself. It's 112 divided by X cubed. What we can do here, guys, to find X cubed, we'll use another easy example method. So I notice this is just a division problem. 112 divided by X cubed is Y. What I'll do is I'll find a simple division problem. So 5 is equal to 10 divided by 2. We're trying to solve for X cubed. Basically, we're trying to solve for 2. To get 2, we do 10 divided by 5. Hence, to find X cubed, it's basically 112 divided by Y. So 112 divided by y is x cubed. Now to find x, we cube root. Because it's cubed, we cube root both sides. So x is equal to the cube root of 112 over y. So that's that formula, found the subject of that. So now we have two equations. They're both equal to x. If both equations are equal to x, we can deduce that these two equations are equal, okay? So we can write 3w squared is equal to the cube root, of 112 over y. And we want to find a formula for y. So we want to get y by itself. Well, it's 112 divided by y, and it's being cube rooted. So let's get rid of the cube root. Well, the opposite of cube rooting something is cubing it. So we'll cube both sides, So we'll cube this, and we'll cube this. So 3 cubed is 27, and the inside-outside indice rules, you multiply them. So w to the power 6 is equal to, here, the cube and the cube root cancel out, so we're just left with 112 over y. Then we'll go back to our easy example. We're trying to get y by itself. So 2 by itself. So we'll do 10 divided by 5. So y is equal to, 10 divided by 5, so it's going to be 112 divided by 27w6. And that's our formula for y in terms of w. All right, it's a tough one, guys. That's definitely an A or A star level question. And on the next page, I'll give you some questions to try. Hey guys, here's some questions about inverse proportion that you're welcome to try. 1, 2, 3, 4, doing in this order, 5. This question is actually about direct proportion, but just about combining two different statements together. And just to clarify, that this means it's directly proportional, okay? Like I wrote it in this sentence over here. And same as the relationship between z and y. All right, give it a shot, guys. Thanks.